All right, so now we're ready for chapter 19. We're going to get all mixed up here and talk about how chemicals mix. All right, first of all, when you talk about the difference between a mixture and a compound, okay, a compound is when two elements have been combined together. They always match up in the same proportion. For example, sodium chloride or salt always has one sodium atom for every chlorine atom. Okay, so they have the same consistency, which could also be true of a mixture. But the sodium and chlorine have completely different properties than they did when they were separate. Chlorine, for example, is a green, poisonous gas. All right. Sodium is a highly reactive metal. If you put it into water, it blows up, basically. All right. And yet, if you put them together, they make table salt, which we put on food to make it taste better. Okay. Salt has completely different properties. Sodium chloride has completely different properties than either sodium or chlorine by itself. Okay. A mixture, on the other hand, is a combination of two or more substances in which they retain their own properties. So, for example, say if you have salt water, it still has the properties of water, still has the properties of salt, tastes salty, and so forth. But they keep they're mixed together, but they keep their own properties, and they don't always have to be in the same proportions. Just like sodium chloride always has one sodium for one chlorine. You could put twice as much salt in one batch of salt water versus another batch of salt water, and it's a mixture still, but it's still salt water, but it's not the same strength or concentration that's been mixed at. And so basically, that's getting that out of the way first of all. We're not talking about compounds right now per se. We're talking about mixtures. And chemists began to classify matter into different groups. Okay, let's start with a matter. We can divide it first of all into pure substances or impure substances. Pure means a material consists of only one kind of element. For example, we could have gold, pure gold, or we could have pure copper, or we could have something of this. Or it could be a single compound. Okay, we could have sodium chloride. It's pure salt, nothing else in it. Okay, for example, salt is dug out of the ground, but that is not pure salt. It's got other impurities and things mixed with it, and so it has to be purified to make the table salt that we eat, sodium chloride. So pure is a material that has just a single element or a single compound and nothing else in it. Now, having said that, 100% purity does not exist. There is no such thing as 100% pure. It just doesn't exist because it is impossible to make sure that every single atom of a substance is, for example, gold, or that it is salt, or something like that. So, for example, pure gold is 99.9% gold. And if it's that close, then we consider that pure gold. Okay, even though there may be, obviously, some other random atoms of other elements in there. Okay, so that would be considered pure. Okay, that's about as close as we can get. If you have 24 karat gold, that's what you're getting. You're getting 99.9% gold. Okay. If you get 22 karat, for example, though, 22 karat is only 91.6, or about 92% gold. Okay. If you have 18 karat gold, it is down to about 75%. And finally, if it is 12 karat gold, that's about half of 24, so it's going to be 50% gold. My wedding ring is, for example, about 14 karat, so it's a little over half gold. Okay, and of course the other things are added to make it stronger, and so it doesn't get bent and tore up like that. Okay, for example, sometimes they add copper to the gold to make it more reddish. Okay. All right, or you can add more silver to make it a certain type of gold, and so forth. And so they can add different ones. There's rose gold, which is gold plus palladium plus copper plus silver, a little bit of that. Okay, so you can make different colors and combinations depending. But if it's pure, that means it's just gold. Okay, or as close to pure as we can get it. All right. Now, pure does not mean the same thing as it does in food. You know, about orange juice or something like that. It says pure orange juice. Well, it means it doesn't have anything else added to it. But it obviously is not a pure substance. It's got pulp. It's got different chemicals in it. Lots of different chemicals in the orange juice itself. Okay, so you may hear the word pure talking about food, and that's the difference than what we're talking about as chemists. As chemists, we mean it's 100% just one compound or one element. All right. Now, under impure, then, everything else, we have two major categories, and we can either have heterozygous mixtures or homogeneous mixtures. Okay, hetero means different. Okay, heterosexual means two different sexes. Okay, so hetero means different, and so a heterozygous mixture is where you can look at it and you can see that there are different things, different compounds, so forth, mixed in it. Okay, so for example, some examples of heterogeneous mixtures. That big enough we can see it, maybe. Pizza would be an example. You can see it. There's obviously different things making it up. A snow globe, you got different things. Granite is a rock, and it's all granite. It could be 100% granite, but granite has different colors. You got dark, black, and you got purples and grays, and different colors that mix in. And there's different kinds of granite depending on what colors they mix in and stuff like that. Okay, so those are heterogeneous. Sorry, I'm going to call it heterozygous from biology, but heterogeneous mixtures. They have, you can obviously see that there are different things. If you had pulp floating around in your orange juice, you can see that that obviously is different. Sometimes in muddy water, you can see big soil particles and stuff that are mixing in there. Sand, if you look at sand very closely, very rarely it's all the same color and all whatever. It's at different sizes. It's definitely heterozygous. Okay. Italian dressing would be an example. You obviously have oil and you have watery, more water-based parts, and you have all the little stuff floating in it. So it's very heterozygous. It looks different. You obviously have different things mixed in it. Okay. Now, if we go into homozygous, all right, homozygous means the same. Homosexual means same sex. So basically, homozygous means the same. So in this case, you have a mixture where everything looks the same. Just to look at it, it looks the same. All right. And it has about this, but within the mixture, it has the same ratio of substances throughout. There's not parts of it that have more of this and more of that. It looks the same all the way throughout. It has the same ratio of substances and so forth. And individually, you can't see the separate parts. It looks to be all the same thing. Okay? Now, an example of that, or we break that down into two things. There can either be solutions or there can be suspensions. Okay? A solution would be something where all the components are mixed in the same phase. Okay, for example, salt water. You have salt mixed with water, but now it all looks the same and it's all in the liquid phase. It looks like it's in the liquid phase now. Alloys, where you mix two metals together. Okay, and when you look at the alloy, say bronze on a lamp, you can't see the copper in it and the zinc, or that part of it's copper, part of it's zinc. It all looks the same. Okay, and you can't pick out one part from the other. Okay, so it can be liquids like salt water. It can be solid like alloys, metals put together. It can be gas and air, or gases like gas and air mixed together. You can have oxygen dissolved in water. If you look at two aquariums, you can't look at it and tell which one have oxygen dissolved in it. The fish will tell you that if they start dying, then obviously it doesn't have any oxygen in there, but you can't see it. It looks, the oxygen is dissolved in there, and you cannot tell if there's oxygen in there or not just by looking at it. Okay? And so that's a solution. One thing is dissolved or mixed completely into another. All right? A suspension, on the other hand, is you have different components, but they are different phases. Okay, so for example, if you had blood, blood looks to be just red stuff. Now, at some point, if you look at it under a microscope, it will look to be heterogeneous. Okay, because you will see a bunch of red blood vessels for blood things. If you actually take the liquid part of blood, it's plasma. It's going to be kind of yellow, clearish stuff. Okay, so it is considered a suspension. Okay, because there are parts flowing around it. Milk looks like it's homogenized. It's been homogenized or mixed together, so it all looks the same, but it's got fat particles and water particles and sugar particles and various things floating around in it. But it's been shook and treated to make it homogenized. That's what's called homogenized milk, so that it all looks the same. It's suspended. Now, they can be more easily separated. For example, if you take blood and put it in a centrifuge, which is a spinner, it spins it around really fast. Okay, it will cause the blood cells to separate out at the bottom. You'll have the red blood cells, and you'll have the white blood cells, and you'll have a yellowy white stuff at the top, which is just the liquid part, and it will separate them into their different parts. But just to look at it, you can't see those different parts. Okay, but a suspension can be settled out, whereas a solution, they will stay together. If you shake up basically, that's different. You can separate the different parts of milk. Okay, you can separate the whey and the curds, and that curd is all the fatty stuff in there, and the whey is more the liquidy part of it. Okay, same kind of thing. It can be separated, but it may be difficult to do that. Okay, but you can do that. You can separate it back out. But once it's mixed together, you can't tell one part from another part. Okay, now of those, we mostly want to talk about solutions. Okay, solutions are where chemicals react with each other most of the time. In a suspension, they're just mixed in it, but they'll settle out of it, but they're not really reacting with each other. You've got stuff that's floating in a different medium, like the blood cells in the blood or the fat particles in the milk. But it's solutions is what we really get into, where we want to, chemistry, we want to react things and mix things together. So by far, probably the most one that we deal with a lot of times will be solutions. Solution for a little bit, because everybody wants to be part of the solution, right? Part of the problem. So let's talk about solutions. First of all, solutions has two parts. You have a solute, not a solute, but a solute, and you have a solvent. Okay. Generally speaking, we say that the solvent is the component present in the greatest amount. Okay. But in general, the solute is what is being dissolved and a solvent is what does the dissolving. All right. So, for example, if we have a solution of sugar water, or sucrose in water, sugar water, basically, we would say that the water is the solvent. It's what dissolves the sugar, which is what's being dissolved. So sugar would be the solute, and water would be the solvent. Okay, but for example, in the air, you have just a bunch of air molecules all mixed together. Okay, some of them are nitrogen and some of them are oxygen. Well, is the oxygen dissolved in the nitrogen, or is the nitrogen dissolved in the oxygen? Well, it's really hard to say. They're just two gases that are mixed together, and you can't really say that one dissolves in the other. So we would just say whichever one there's more of is the solvent. So in this case, nitrogen would be the solvent, because the air we breathe is 75% nitrogen. Only about 18% of it is oxygen, so that would be the solute. Okay, other things like helium and hydrogen and carbon dioxide and water vapor and whatever else might be in the air would also be solvents in the nitrogen, because there's more of it. But generally, if we're talking about a solid and a liquid, we will say that the one that does the dissolving is the solvent, and the one that is getting dissolved is the solute. Okay, think of paint thinner and paint. Paint would be the solute, and it would be dissolved by the solvent or the paint thinner. Okay, so anyhow, now when they dissolve, or sometimes called dissolution, you don't hear that very much, but just in case you do hear it, dissolution or dissolving. Okay. All right. When that happens, depends.